to speak here today. The case study topic for today is I would like to bring you to one of the very amazing projects in Singapore that has been recently completed last year. The project is the Marina Bay Sands Integrated Resort in Singapore. So I'm going to talk about how are we going to actually adopt the structural steel design in the super fast track projects. The project started in 2007 and completed in less than 3.5 years. In 42 months, the project actually is very iconic and very challenging project in Singapore, and now becomes the new icon of the Singapore downtown. Now let's go back to some fundamental first. Structural steel. What is the advantage of the structural steel? Today, I think we have heard more than enough, right, what the structural steel benefit can actually give to a building project or infrastructure projects. But very briefly, let's go down to the bullet points here. Structural steel actually have a very high strength to weight ratio, and in fact, that is the most important advantage in terms of structural design. Saving foundation costs, saving time, we mentioned several times today, right? We can actually use structural steel to achieve irregular shape in particular for building design, for building projects. Structural steel is one of the lightweight material in compared with concrete structures, of course. So what are the merits of the lightweight materials? It can actually, very obviously, impose lighter loading to the structures, such that we can enable smaller structural members, save costs in foundations and structural costs, enable fast constructions, easy to handle and install. Again, we have heard different presenters actually today mentioning about how we can achieve to minimize the red trade work on site, how we can save construction times in the foundation and the superstructure as well. In terms of design, we can achieve a better aesthetic outlook because it is suitable for irregular shape. Slimmer outlook can be achievable. Provide better architecture because we can have a higher headroom because of the lighter weight and smaller, because of the high strength ratio of the structural steel. And in particular, in building design, it is suitable for long-span structures to create more internal space. In the following a similar project I'm going to do for the Marina Bay Sands, actually you can appreciate how the structural steel can cater for long-span design for structures. Now, here are some examples that around the world that have been done by Arab. We heavily use structural steels. That is the tallest building in Hong Kong, the ICC, or what we call the International Commerce Centers in Hong Kong. The project was completed last year. 110 stories, 485 meter tall, the tallest building in Hong Kong now. Guangzhou TV Tower, mainly structural steel building. It is an observation deck and also the tallest building in Guangzhou and the Shenzhen area. And that actually is for the opening, was opened in the last Asian Games that hosted in Guangzhou last year. CCC TV Tower in Beijing. Again, that project is again heavily adopted structural steel design, and it was completed in 2008, the same year as the Olympic Games hosted in Beijing. You should be very familiar with this one, where we host the Olympic Games in 2008, Beijing National Stadium, or what we call the Bird's Nest. Right next to it is the Water Cube, the National Aquatic Centers. Right, again, it's one of the major venues for the Olympic Games in 2008. Now let's come to the MBS, or Marina Bay Sands in Singapore. That is an integrated resort. That is a photo completed, taken by myself last year in June. This is how the story projects completed within 2 minutes. Now, this is the project. The project actually is comprising a GFA of about 6 million square foot. It comprises 3 hotel towers, and on top of the hotel towers, there's a sky park connected on the roof of the towers. We have a MICE facilities, which is exhibition hall in nature, a casino hall in the middle, 2 2005-seat theaters, and museum structures at the waterfront. And we also have the event plazas at the waterfront, some a retail mall stretching from the north to the south, and also 2 crystal pavilions floating in the water. Now here are some architectural facts for the project. The size is 16 hectares, GFA, as I said, close to 6 million square foot, 5-level basement, close to 3,000 number of car parks, hotel rooms 3,000. And the height of the hotel towers close to 200 meters. Engineering facts. The sky park actually connecting to the rooftop of the hotels are spanning 66.5 meters. And the roof structures is spanning about 80 meters. Diagram wall, more than 4 kilometers. And the total excavation volume is talking about 3 million million meter cube. Now, steel tonnage reinforcement is 300,000 tons, and the structural steel for this project with a total tonnage of about 52,000 tons. Give me a guess. Do you think the structural steel we use here for the project, 52,000 tons, is more than the total tonnage used for the stadium in Beijing? Which one is more? The answer is the Olympic sands, 52,000 tons. For the whole stadium in Beijing, we only use about 45,000 tons of steel. So then you can imagine how much structural steel that we would use in this project. Bear in mind, completed in 42 months before this iconic and challenging design. Now the challenge for the project is against time. As I mentioned several times already, we completed the project in 42 months. We only been given about 3.5 years to complete the project, including design and constructions. Building on reclaimed land with a very thick marine clay deposit, that actually renders the difficulties and challenge in the foundation and the basement excavation as well. Long-span structures, sky park, long-span roof, and also iconic structures, the museum at the waterfront. Now these are all the challenges for this project. The solution to that is we had to introduce innovative foundation design. We introduced 4 big cofferdams. It's a circular cofferdam to facilitate excavation for the deep basement in the marine clay, the very soft marine clay. The diameter of the donut or the cofferdam, if you like, is probably about 120 meters, possibly the biggest in the world. Use of BIM. Earlier today, Thomas Santi talked about the BIM technology. For this project, we 100% fully utilize BIM technology for documentation and for our structural preparations. And we have to divide the work into different packages in order to have the staggering, overlapping, and procurement, such that we can achieve the project or complete the project within 3.5 years. Structural steel work, as I said, right? 52,000 tons of steel work to use in order to speed up the construction time and also to facilitate off-site application and then the same time on-site. Now this is the full BIM model for the project or for the structures. We 100% document the project with the BIM technology. Let's go to the sky park. This is the sky park. On the right-hand side is a completed photo. It's a photo of a completed structure. On the left-hand side, this is just an image, architectural image. This is the BIM model. But there's some facts of the sky park. The cantilever, as I said, right, 65, 66 meters long. Actually, this is as long as a 747 commercial aircraft. 200 meters above ground, 240 meters long in total, and that is possibly the world's longest public cantilever at that height. In terms of structural steel, you use 7,000 tons of structural steel for only the Sky Park. And we lift up the whole thing, the 7,000 tons of steel, within 3 months. Of course, the fabrication off-site, it takes almost a year. We have to overlapping the design together with the construction program of the towers. We have a very, basically a seamless program, such that when we completed the roof of the hotel towers, all the structural steels are ready on the ground to lift up. So we only spent 3 months to lift up with 7,000 tons of steel. Now here is the few slides showing how the contractor lift up the structures. Now on the left-hand side is the cantilever portion, the north cantilever. But between the towers, we have bridge sections. Basically, we have 2 bridge sections. And we have joints separating the bridge section and the towers in order to cater for the eventual stress, undersizement and under wing loading. Now here we're showing how we lift up the cantilever. We use strand jack. That is the back span for the cantilever. And then we divided the cantilever portion into 5 segments and lifting up one by one using bridge technology, the strand jack. There are some photos showing the strand jack, the bridge section, the back span for the cantilever, and the segments for the cantilever. We use structural steel to make it possible. Imagine if you use conventional reinforced concrete design, right? We couldn't make it, both in terms of design or in terms of retaining the program. We saved 9 months in construction time. In fact, this 9 months is a very rough estimate. I think if you're talking about to build another one using reinforced concrete, I would say the saving in time is more than a year. Here's a structural video showing the lifting of the back span. It took 24 hours to lift up the back span for the cantilever. We started at 6 o'clock in the morning and completed the other day. And the Sky Park design was completed